All right, so here we go. So for question number 18, simple strategy. All right, this is standard form. All right, so because this is standard form, it's not in vertex form, you have to find the axis symmetry, which is just negative b over 2a. So that just makes it 10 over 2, which is equal to 5, if I'm not mistaken. Now to find the vertex, you just plug 5 in. And that looks to me like that's 5. What's the matter, guys? So he can listen. All right. And I posted the video. That's what the rule is. Come on, Sam, pay attention. I'm hearing you guys discuss it. I'm explaining it. So the vertex now is what? I think it's 5, 5, right? So that makes the y-intercept what? 0, 30. Now remember, the vertex and the y-intercept are points. The axis of symmetry is a line. All right, the axis of symmetry is a line. All right, so the first thing we want to do is we want to just go ahead and graph x equals 5. So we can do that. This was x equals 5. Now the vertex is 5, 5. So we'll graph 5, 5. The problem is I really can't graph 0, 30. All right. So we review what A is. A is what? 1. So is there a stretch? No. So from there we can just go what? I like to say over first because it's not a slope. So we're going to go over 1 and what? Up 1. Then we use the axis symmetry. Right now we could draw it from there. All right, but we could create another point and say I went over 2 and up what? Up how many? 2 or 4?
4.
4. Why is it 4? Because it's x squared. So we'd go up 4. 1, 2, 3, 4. Put another point there. Measure over 2 units of the axis symmetry. Measure 2 over. All right. And then we're just connecting the dots here. Trying to. Like I said, the nice thing that they've incorporated is it allows you to create the graph. Very simple. All right, anybody else? Tell me. Same principle, right? So you see, what's the y-intercept? Number 11? Did you ask me about number 11?
Yeah.
What's the y-intercept? Come on, guys. 0, c is the y-intercept. What is c? 0, -4. All right, so the axis symmetry, there's a bunch of negatives here. So x equals negative b, which makes it what? 6 over 2 times a, which is -2. So the axis symmetry is, right, x equals -3. All right, now, again, I'm hoping you can do the mental math here. So y equals negative parentheses -3 squared minus 6 times -3 minus 4. What?
5.
Yeah, you guys are getting wrong answers now. I'm glad you're trying to do it mentally so you can correct your mistakes. What's -3 squared? 9, but what? there's a negative out in front. So it's what? -9 plus 18, which is 9 minus 4, 5. All right, so again, that is just a really good review if you forgot kind of the order of operation there. Easy to make a mistake on that. So now we know our vertex is what? -3, comma 5. All right, so now here we go. Graphing x equals -3. Then we graph -3, 5. Axis of symmetry, 0, -4. Now, how far away am I from the axis of symmetry? 3. So I just count over 3. And we're good. Now, just to show you something, look, guys. Normally we would go over 1 and what? Over 1, and this time down 1. So we're just going to see if the points are accurate. Then normally we would go right 2 and what? Down 4. 1, 2, 3, 4. Measuring. Now, normally I'd go down or to the right 3, and now what? Down 9. And guess what you notice? That's on there. All right. Does everybody see what I'm saying? All right. So now, do me a favor and sketch the graph. Looks pretty close. Now, I feel, you know, I'm not sure, but I think everybody should be able to type this out on the calculator, look at it, and correct your mistakes. All right, so now everybody go to their calculator and type in y equals -x squared minus 6x minus 4. And let's calculate is that a max or a min? All right, that's a maximum. Just in case something happens on your test, you forget something. All right, you can double check your work. Calculate the max. Remember what I told you. Second calc, maximum is which one? 4. Now, remember, you move your cursor to the left. But I also showed you yesterday that you could just type in any number to the left of that vertex. So if you wanted to type in like -7, that would be okay. And then it comes up right. You can pick any number to the right. So 0 is to the right, and then you hit enter. That will prevent you from having to hold the cursor down left and right until it moves to left and right. And then the last step is enter. And then you have to remember to just round your answer if it's necessary. Now, again, guys, I can't emphasize this enough. Most people in Algebra 1 have a hard time with these graphs. All right, this is a big part of your SAT, understanding graphing quadratics. All right, so I don't mind the questions, but I feel like you should be able to check your work with a calculator and see if you can make your own correction. All right, now before we get going, does anybody else have anything they want to show me or ask me? All right, we did 2 standard forms. The vertex form is kind of easy, correct? All right, so I feel like I should check the homework, all right. So is everybody good? Anybody? What? Anybody else have a question for me? All right, let's go ahead and let's get down to reviewing, all right, the rest of quadratics. Now remember, solving by factoring, all right, is using the 0 property. What was the 0 property? Set it equal to 0. Why do we do that though? Because if A times B equals 0, what has to be true? One of them has to be 0. All right, that's the 0 property. All right, so number 21 is a good one. What does that factor to, guys? Yes, x minus 4 and x minus 6. All right, now 12 and 2 also works. What's wrong with 12 and 2?
They don't.
If you were to factor it, it would be x minus 12 times x plus 2. That's negative 10. And that's negative 10.
But it also doesn't make negative 24.
That's correct. Negative 12 times positive 2 would make this a negative 24. All right, that's why that one's considered a little bit harder. All right, because there's 2 ways to make 10. You have to make sure you do it the correct way. So this was bad. All right, now from here, you just set it equal to 0. Is everybody good with that? And now I don't expect anything else but the answer, right? So we just say x equals 4 or x equals 6. Anybody have any questions? All right, so let's review 22. All right, let me give you a second to factor number 22. All right. Should be kind of easy.
Is it 4 plus 5 and 2x minus 3?
10x right here and negative 12x. 10 minus 12 is your what? Negative 2. And then 4x times 2x is your 8x squared. And then, of course, your positive 5 times negative 3 is your what? Negative 15. So is that correct? Yeah. Yes. Wouldn't it be positive 2? Why do you think that, buddy?
Because positive 5 plus negative 3.
Okay, so here's your mistake. Here's your mistake. And it's common because I didn't teach you factoring. So a lot of whoever taught you factoring, there's different techniques, but this is the way it should be done because it's going to help you be better at factoring. All right. So now I always show kids smiley faces. So you're connecting these two. So how much is this when you multiply that together? 10. And then this outside is what? And that's where we're getting the negative 2x. Right? It's not just, listen, it's not just from these two numbers. Right? It's the product of these two and the product of these two that you're looking at. That's why I don't let kids generally put the sign until the very end. That's to me the last step. All right. The first step is seeing the combination of numbers. All right. Hopefully that helps. All right. And again, that's extremely important, Simon. So if something's not correct, you tell me. All right. So what do we say it was? It was plus 5, correct? And minus 3. And then so from here, I don't expect anything but what? The answer. Everybody can solve a two-step equation in here. So it's just x equals what? Negative 5/4 and x equals 3/2. Now, again, it's a review. So if some strange reason you miss class, everything is what? Recorded, and I'm posting it. So feel free to listen to it again. All right, if you're not sure about something. All right. Anybody have any questions with the review of factoring? All right, so now your job is to do 23 and 24. All right. Now let's review solving a quadratic by taking the square root. You solve a quadratic by taking the square root when there is no x term. There's just an x squared term. All right. So for example, 25, we know we can just take the square root of both sides. So tell me that the answer is. There you go. Everyone forgets. How many solutions are there in a quadratic? 2. So that's helpful. So it reminds you that it's a plus or minus. It's plus or minus. All right. So now let's just jump to the hard one, 28. All right, what do I have to do first? You definitely can't distribute through a square. You have to what? You have to isolate, right? You have to isolate the square. All right, so you are correct. What do I have to do first? Add 3 and then what? Add 3 and divide by 3, which I think everybody here can do. So if you add 3 and divide by 3, you end up with x plus 2 squared. Someone tell me. Equals 6. Anybody have a problem with that? Now you take the square root. So then you say x plus 2 equals what? Nope. What? Nope. There you go. Plus or minus radical 6. That's where everybody makes their mistake. And so from there, you would just then write x equals -2 plus or minus radical 6. Now, the purpose of this review was to kind of keep it small. All right. Each little review section has a few problems. And it's supposed to, okay, I remember that. All right. If you don't remember that, you can speak up. All right. Is everybody comfortable with that? That's not bad. All right. That's solving a quadratic by taking the square root. All right. And you only use that when there is no x term. When there is no x term. All right. So finish up. Try 26 and 27 tonight. Oh, well, actually, I didn't realize I gave more. All right. So let's try 31. All right. What do I have to do on 31? Combine the x squared. So what's that going to be? 2x squared equals what? 250. So x squared equals 125. And of course, we take the square root. And so we know that x is equal to what? Somebody help him. Say it.
Plus or minus 5 radical 5.
That's exactly what I need out of everybody. They'll look at you crazy next year. If you can say the square root of 125 is 5 radical 5. You're not even supposed to look at 125. All right, that shouldn't even register. You should automatically see that's just 25 times 5. All right, then break it down. Does anybody need any help with how we broke that down? All right, we've worked on square roots quite a lot throughout the year, so I didn't think that would be that big of a deal. All right, let's try 32. Say it. No. Someone else tell me. So what's the answer? No solution. There is no solution. All right. How do we know that again? Yeah, when you square a number, it's never going to be negative. When you square a number, it's never going to be a negative until next year. All right. They will introduce what's referred to as imaginary numbers. All right. Yeah, it's a wrong choice of words, actually. All right. But yeah, they're called imaginary. All right. The square root of -1 is imaginary. And if you look under your decimal point, there's an I. All right. Your calculator can do the imaginary numbers also. All right. It's really interesting. Okay. So let's just do 34 just to make sure. All right. So x equals, and I'll wait for the answer. All right. As soon as you know the answer, you can tell me. All right. And then we'll see if everybody else is good. I'm listening. Go loud and proud.
Plus or minus
I have no idea what you're saying.
Oh, I got it.
Tell them
I got x equals 7 plus or minus 2 radical 6.
you are amazing. You see what you did? Yeah.
Yeah, I got it.
Everybody okay with that? Now, remember, guys, I also would like for you to tell me that this right here is an irrational number. Everybody's listening. This is irrational, and this is what? Rational. Can you add irrationals and rationals together? No. All right. That's a common mistake. All right. Now, does anybody need an explanation on 34? Anybody need an explanation on 34? What? Well, if you add 4, what do you get? Shh. 24. What's the square root of 24? And then what do I do? William, you good?
Yeah.
You sure?
Yeah.
All right. Again, most of the time it's just, forget a little bit here, a little bit there. All right. Anybody? Anybody? All right, here we go. Now, the annoying part was the quadratic formula. All right. So again, something that you definitely want to know. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's referred to as the quadratic formula. So that allows you to solve any quadratic equation. All right. Now, if you also remember, the equation was ax squared plus bx plus c equals 0. All right. So you're just plugging numbers into a formula. All right. And the only time you would want to do that is when you cannot factor it. So I'd like everybody to take a look at number 35. If I told you to solve that by using the quadratic formula, would you? There's no reason. I would never ask you to do something that's going to take a long time. All right. If you can just look at it and tell me the answer, that's the objective. Get the answer. All right. If you use the quadratic formula or if you factor, will you get the same answer? Yeah. All right. So if you can look and say something that's easily going to factor, I'm not using the quadratic formula. Those of you guys that are horrible at factoring, just use the what? Quadratic formula, and you'll get the right answer. It just requires a lot more work. All right. So 35, obviously, I don't want to use the quadratic formula. All right. We would just do what? Now, does everybody understand that? How to remember if it factors or not? All right. To remember if something factors, you always multiply a times c together. So in this case, a is what? 1. So if you multiply a times c, in this case, you're going to get what? -8. Now the objective is the factors of -8. Is it possible that that sum is equal to -2? Why not? What would the factors of -8 that add up to -2 be? So I know it factors. All right, so I know it factors. All right, that's how you tell. Multiply a times c, and if those factors of a times c can add up to b, then it can factor. If not, it doesn't factor. So in this case, we just go ahead and factor it, and I'm not going to waste my time on that. Let's do number 36. Does 36 factor? No, because there are no factors of 2 that equal -5. All right. So here we go. Quick review on quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And for those of you guys who are getting ready to take standardized tests, they're going to ask you about the quadratic formula. So if you don't know it, or if you're fumbling through it, that's why I told you last year, after every problem, you should write the formula. All right. If you don't know the formula, write the formula every time until you commit it to memory. All right. Then it'll be easy when you take your test. All right. So here we have x equals what? 5 plus or minus. Now here I just always say square b, and what's that? 25. I try to tell kids you really shouldn't try to multiply all those together at once because that's where you make mistakes. So this would be 25 minus 4 times what? Times 2 all over what? 2. Is everybody okay with 2? All right. So now you can kind of look at that and say x equals 5 plus or minus. And now we just look at that and say that's obviously 17 all over what? 2. Now, if you could break down the square root of 17, you would, but obviously we cannot break down the square root of 17. All right. Does anybody have any questions reviewing the quadratic formula? Okay, so let's do one that might cause a little bit of trouble here. Let's take a look at number 42. All right, so here we go. X equals, what do we got? -2 plus or minus the square root of 4 minus 4 times 4 times -7 all over what? 8. Everybody good with that? Okay, and so now we have x equals -2 plus or minus the square root of . Stop. What are you guys talking about? And some of you all grabbing your calculators like you're crazy. What is it? Yeah, 116 all over what? 8. All right, now the annoying part is we know that 116 is divisible by 4 because the last 2 digits are divisible by 4. But is there something else? Well, I mean, 4 is better than 2. I'm trying to break down the square root of 116. Is that correct? So now we have -2 plus or minus 2 radical 29 all over 8. Is everybody okay with that? Now can you reduce by a factor of 2? Right, does everybody agree? You're reducing both of those by 2, right? So this would be x equals what? -1 plus or minus radical 29 all over what? All over 4. All right, that's not showing up so good.
It's 2a. It's over 2a.
All right, I'm pretty happy with that. All right, now the next thing that was kind of important, and it will be important for your algebra 2, all right, is solve by completing the square. All right, that's how they discovered the quadratic formula, was by completing the square. So let's just review that. So 45. Again, I started with something basic, all right, just to review with you. Now, can I factor 45? Yeah, I can factor 45, but the point was, all right, I would just go ahead and factor it, but I want to show you an easy completing the square. All right, so again, we're going to work on completing the square. And then some of you are like, well, why would I do that? I'm saying I wouldn't do this completing the square. I would just do what? Factoring. But I want to give you one that's really easy so you can review the steps for completing the square. All right, so when we completed the square last year, we would do x squared minus 2x. We would leave a space, and then we would put the constant on the right side of the equation. Then when you complete the square, the rule is you always take half of b and you square it. All right. Now, why is that? Why is it called completing the square? Because you're trying to make this a perfect square. You're trying to make that a perfect square. So what's half of B? And when I squared, it's what? So you're adding 1 and you're adding 1. Now, what does that do with x squared minus 2x plus 1? It makes it a perfect square. So what does that mean? That means that it factors into a perfect square. It will always create a perfect square. So now x minus 1 squared equals what? 9. And so now we do what? Take the square root. So x minus 1 equals what? Nope. Plus or minus 3. And so our final answer is x equals 1 plus or minus 3. All right. And what's 1 plus 3?
4.
And what's 1 minus 3? So those were our two solutions. All right. Now, how did I already know those were the two solutions? Because I can look up there and say that's just obviously x minus 4 times x plus 2. So x equals 4 or negative 2. Same result. And guess what happened if I do the quadratic formula? Same thing. There's multiple ways of solving quadratics. All right. Completing the square, we don't ever do completing the square really until you get to algebra 2. All right. When you're finding the vertex form of a parabola, all right, or, you know, an ellipse or a hyperbola, those types of things when you need to know how to solve by completing the square. All right. So now I'll do one more with you. Let's do 46. All right. Yeah, I know. I just got kicked off somehow. Here we go. Let's try this again real quick. All right, back in action. All right. Now, again, the objective is to make it a perfect square. So the first thing I need to do is move the positive 2 over. So that becomes x squared plus 6x. Leave a space, what? Equals what? Negative 2. All right. So now what am I adding to both sides?
9.
Now it's the time to speak up, please, if you don't know why it's 9. I'm adding 9 to both sides. Anybody? And now it's what? It always factors into whatever the half was.
X minus 3 is good.
Close. X plus 3, because half of positive 6 is positive 3. Agreed? So it always factors into whatever the half was. So it's x plus 3 squared equals what? 7. All right. And now what? Yeah. Now, listen, guys, for me, you know, I always did a lot of the work in my head, and I always remember the teachers screaming and like having convulsions because I didn't show all their work. I think it's important that you can do that, right? So if you look at this and say, obviously, this is how I want you guys to be. X equals negative 3 plus or minus the square root of 7. Right? I just think everybody should be able to do that, right? You're taking the square root, then you're subtracting 3. I don't feel like writing all that stuff out. All right. If you can do that, what? Great. If you can't do that and your teacher flips out next year and says, well, how did you get the answer? Say, because I can do math good. All right. Or you can say, okay, I'll show all my work. All right. If they say show all your work, you know how to show your work. All right. But if you can tell me the answer, just give me the answer. I'm good with that. All right. Negative 3 plus or minus the square root of 7. All right. Now, I feel pretty good. But what we're going to do now is I'm trying to, help you guys out, meaning I really don't want to give you a whole bunch of homework. And last night I asked you to do some things and I feel like some of you didn't get it done. So you're going to have an opportunity tonight to get the rest of those graphs done. But what I want to do right now is not assign homework, but I want you to take out your calculator because I'm going to now review with you how to get this answer on your calculator. All right, I'm going to review with you how to get this on your calculator. All right, but the first thing above this, I want you to realize that this means y equals 0. And if y equals 0, we're searching for the what? Thank you, whoever said that so quickly. I appreciate that very much. We are searching for the x-intercepts. That is true. We are searching for the x-intercepts. All right. Now, the x-intercepts are also called the zeros. Why do you think they called them the zeros? Because that's when the what? Y value is 0. All right. That's because the y value is 0. That's what you're looking for. And if the y value is 0, you're looking for the x-intercepts. So now I'd like everybody to graph y equals x squared plus 6x plus 2. Y equals x squared plus 6x plus 2. Now, when you graph that, all right, it should come up with something like this, maybe. Is this correct? Something similar to that. All right, so what we're looking for is this right here, and we're looking for this right here. All right, so let me review with you how to do that on your calculator. All right, so everybody go to second calc, and the menu drops down, and it says what? What are we looking for? We're looking for the zeros, aren't we? Right? We're looking for the zeros. Which number is that? Number 2. All right, now listen to what I'm telling you. It first is going to come up left bound, correct? So you need to move to the left of this 0. Now, do you have to move to the left, or can you type in a number to the left? You can save you some time, you type in a number. So I'm just going to type in -7. And then what's to the right? 0. And then when it says guess, you just hit enter. All right, and what number comes up? X equals what? Somebody said 0.3 what? Okay, so what I'm showing you is it possible to convert an irrational number to a fraction? No. Is it possible for your calculator to convert the decimal to an irrational number? It's not possible for the calculator to do that. So what I need you to do now is I need you to look at this number right here and then go back and do -3 plus the square root of 7 on your calculator. And it should be exactly the same number. And then you calculate the other 0. And it would be -3 minus the square root of 7. And the other 0 would be found. Yes.
I didn't get -3 or 0.3542.
That's right. You got what?
No, it's not that.
Tell me again. You got what?
0, -0.425.
Then I think you made a mistake then. Make sure you type it in correctly. X squared plus 6x plus 2. Also, you have to hit, when it says guess, you have to hit enter a 3rd time. All right, come on, guys. I don't have much time. All right, what?
When I click enter, when it says guess, it turns into error. Yeah.
That means you didn't go to the left and to the right. Right, so look, guys, real quick, look up here because I don't have much time. Look up here, please, and we'll continue this tomorrow because I think it's super duper important. Here's your cursor, right? So I'm here. If I want to find this 0 here, I got to move the cursor to the left and hit enter, and then move the cursor to the right and hit enter. And then it'll say guess, you just hit enter a 3rd time and boom, it'll put it right there. Right? The other thing you're going to do is if you want to find the 0 on the other side, you hit second calc 0, move your cursor to the left, which is right here, and then move your cursor to the right, and then it will give you what? It'll give you this one. Is everybody with me? All right. Okay, so now I'm running out of time here. I just want to make myself perfectly clear. Guys, I am trying to prepare you just for your next test. All right, our next test is Friday over these quadratics. It's just going to be over this worksheet. I'm not even going to give you another review. All right, we're just going to knock this out. If you can do everything on this worksheet, you will be fine. All right, if you can't, you might have some trouble. All right, I'm telling you, you got to judge for yourself how good you're doing. All right, I'm expecting tomorrow now. I had a lot to talk about today. I was going to surprise you and look at all the graphs and make sure you did your homework. All right, so I'm giving you a little bit of extra time. This chapter is super important for you to separate yourself between the other kids that have taken Algebra 1 and that are taking a placement test. All right, these are the ones that generally kids at the end of Algebra 1 don't remember how to do all this stuff. All right, so that's why it's important for you to constantly review, do the little bit of work that I'm asking you to do, but do quality work. All right, doesn't do any good just to scratch things down and move on. All right, quality. All right, that's why I'm saying you can judge for yourself. Do you remember how to complete the square or not? Do you remember how to do the quadratic formula or not? All right, if you don't, you got to practice more. All right. So with that being said, I think today was a good day. All right. And of course, if you're not sure or you want to hear it again,